Hello viewers, welcome back to my channel. Today we are going to continue soil-water plant relationship, what we studied in the last video. Myself is Dr. Sugita, a faculty working in SNS Institute of Technology. So this is a part of the curriculum Irrigation and Drainage Engineering Unit 4. So in the last class, we studied that soil-water plant relationship is very crucial in maintaining the ecosystem balance. So we studied about how the soil depth influences the soil-water plant relationship. Today we are going to continue with the other properties of the soil such as texture and structure. So what is soil texture? The relative proportion of sand, silt and clay which forms the fundamental of any soil textural classes. Based on the soil texture, we are having three basic soils, that is sandy soil, loamy soil and clayey soil. In all these type of soil, the particle sizes varies. If you take a sand, the particles will be ranging in size from 2 mm to 0.05 mm. And here the subcategories can be classified as coarse, medium as well as fine sand. And likewise, the silt particles, the size will be little bit less, the range ranging from 0.05 mm to 0.002 mm. The physical properties of the appearance of the silt may look like a sand, but the characteristic is more towards a clay. Only the soil particles smaller than 2 mm, that is 1 by 12 inch in size, you can call them as soil particles. So clay particles are less than 0.02 mm size, and it is an important fraction because it has the important behavior of water retention or water holding capacity. Among all these three soil particles, you cannot able to see clay and silt with your naked eye. As you know, the sand particle size is much bigger. You can able to see it with your naked eye. In this picture, you can see how the soil is classified based on the soil texture. According to Milton and Whitney in the year 1911, they proposed a triangle. So here the base represents how much is the percent of the sand, and both the sides represents the percent of clay as well as the percent of silt. For example, if you take a clay loamy soil, you can follow the red highlights. It comprises 40% of silt, then 30% of clay, as well as 30% of sand. So this is considered to be an ideal soil. Based on this proportion, you can classify any type of soil as sandy clay or sandy loam or silty loam and so on. So this structural classification is very important. What are the common textural classes one you can find in the field? So based on these textural classes, we are having loamy soil, sandy soil, as well as clayey soil. And the loamy soil you can classify as moderately coarse, medium, and moderately fine. And you can see the examples that are given in the table. In general, the coarse texture soil, they have low water holding capacity. If the soil can be able to hold very less water, what happens? There will be a rapid drainage and air movement. You have to increase the number of irrigation. That is, the frequency of irrigation will be more. Once the irrigation frequency is increased, obviously the requirement of water is more. So it has a direct influence on the irrigation scheduling of your soil. The loamy texture soil is regarded as ideal if you go for irrigated condition, and the fine texture soil, if it is having more clay proportion, the water holding capacity will be more. So what are the impacts of this texture in soil moisture? If the texture is good, the water holding capacity will be more, and it also have an influence on the irrigation depth and frequency. Then it influences the permeability as well as the infiltration rate. So thus the texture of the soil is very, very important. Now we can move on to the soil structure. How the structure influences the soil moisture. So what is soil structure? So the arrangement of soil particles, that is the clay, silt and the sand, how they are arranged is called the soil structure. So when the particles are arranged, there will be some intermolecular spaces, and these spaces we call them as pores, and these pores determine how much water the soil can able to retain. So fine texture soils like clay with smaller particles, they have larger surface area. If the surface area is more, it have a high water holding capacity. Soils like sandy soil, they are more coarser, while the particle size is larger. So when the particle size is larger, the area is smaller. So smaller surface area means the water holding capacity will be less. How the soil structure affects the water holding capacity, it is very important. As agriculture graduates, we have to understand. So first property is the soil texture. This I discussed in the previous slides as well. This arrangement of sand, silt and clay particles which determine the texture, and it have a direct influence on the water holding capacity. Then comes the pore size and number. So when the arrangement of the sand, silt and clay particles are ideal, the pore spaces will be more. So the soil structure forms the pore spaces, and we can say a soil which is well structured will be having a balance of pore sizes, that is macropores as well as micropores. So what do you mean by macropores? The size will be more, and microscope pores, the pore size will be less. Both the size of pores are very important, as macro pores are important for drainage. The excess water will be drained out, and micro pores are very crucial for retention of water. And organic matter content. So everyone knows what is an organic matter. So farmers used to apply this compost, vermicompost into the soil. One important role of this organic matter is to add fertility. Apart from that, it can able to increase the water holding capacity, because the soil organic matter contains humus. Humus in turn contains humic acid as well as fulvic acid, and these components have a high affinity for water. Then aggregation. So how the soil particles is aggregated, forming clumps, it also affects the water retention. So if the soil is having a good aggregation ability, the aeration will be more, and it can able to maintain the pore spaces, which in turn improve the drainage and water holding capacity. And finally, the soil depth, it also influenced by the soil profile, that is the depth of the soil profile. If the depth is more, or the deeper soils, they have more water storage capacity. If we talk about an ideal student, the ideal student is having certain characters. The same way in agriculture, we are having a term called as well-structured soil or an ideal soil. So what is an ideal soil, or which soil you can consider as a well-structured soil? If a soil is having a good balance of pore sizes, if it is abundant in organic matter with favorable aggregation, the water holding capacity of this soil is higher. Once the water holding capacity is higher, the water holding capacity is higher, you can reduce the frequency of irrigation, and thereby you can reduce the quantity of water required for irrigation. So you can attempt an activity if there you can see many soil which is not in a good structure. For example, terry soil, coastal soil and degraded soil. You can consider different types of such soil, and you can think about a plan how to improve the structure of the soil. and you can get back to me with your results. So we will see the continuation in another video. Thank you.